Hi, today we will do square. Okay, so first we will do some examples. So first I will take is 98. First I will do of 98. So let's write 90, 98 here. 98 square. I will find first 98 square. 9 9 is 81. 88 is 64. And if you multiply 9, 8 and 2, then it comes 144. And if we add it, 9604. Okay, so the answer would be 9604. Now we will do another example. We'll take 1003. Here I am doing with another method, that is base is equal to 1000. Then 1003 minus 1000 is equal to 3. 1003 plus 3. 3 6 and 9. 1, 2, 3. 1, 2, so this is a square. 1006 009 is a square of 1003. Okay, so we will learn how I had done this with method. I have done it. We will learn in this exercise. Okay, so this was just a trial. Okay, now we will start a chapter. Squares are the numbers that comes as a result when a number is multiplied by itself. A square can be represented by writing 2 above the number that is to be squared. For example, 2 square is 4. Okay, so here I have done a flow chart that of a table. 1 square is 1, 2 square is 4, and 3 square is 3. 3 square is 9, 2 square is 4, 4 square is 16, 5 square is 25. This is a table from 1 to 20. Okay, 5 square is 25, 6 squares is 36, and 7 squares is 49, 8 squares is 64, and 9 square is 81, 10 square is 100, 11 square is 121, 12 square is 144. This goes on like this. Okay. Perfect squares or square numbers. Okay, so what is perfect square? A square of a natural number is a perfect square. You can see a natural number, suppose n, will be a perfect square if there is a natural number, suppose m, that will multiply by itself will give n. Means m into m always be n, and n here will always be a natural number. Okay, it will not be any number. And m will also be a natural number. Suppose example, you can see 2 is a natural. Wait a minute. 2 is a natural number, so 2 into 2 is equal to 4. 4 and 2 both are natural numbers. Okay, and you can say 3. 3 into 3 is equal to 9. 3 and 9 both are natural numbers, so 4 and 9 are perfect squares. We can also take this perfect squares as geometrical shapes also. Like you can see here one dot. Okay, so there is one dot, there are 4 dots, and the 4 dots come together to make a square. There are 9 dots, and these 9 dots come together to make a square also. So this is why it is called perfect squares. How to check whether the number is a perfect square? Okay, so we know the perfect squares are is if m into m is equal to n, where m is a natural number and n is also a natural number. So how can we check if any number, we don't know which squares is it, but how do we check if it is perfect square or not? We can check with this with the help of prime factorization method. Take a number and divide it by the smallest possible number by which it can be divided. Do this till you reach 0. Then group the number. If all the numbers are grouped in the pair of 2, then it is a perfect square. Then if we multiply all the numbers once, then we will also get the numbers whose square is the initial number. So let's do this with the help of an example. Okay. Check whether 17640 is a perfect square or not using prime factorization method. Okay. So first we will write 17640 and calculate it by its prime factorization method. Okay. So first it can be divided by 2. So we will write 2 and 2 a to the 16, a to the 16, a to the 4 and 0. Okay, then also it will come 2, 2 4s are 2, 2 4s are 2, 2 1s are 2, 2. Okay, then now it's also come 2, 2 into 2 4, 2 into 4 and 2 into 5 5, 2 into 10, 2 into 5 10. Okay, now it cannot be done by 2, so we will take 3 3. Okay, so 3 7 21, 3 3 9 and 3 5 15. Okay, 735. 735 can also be done by 3. Okay, so 3 to the 6, 3 for the 12, and 3 for the 15. 145. 145 cannot be done by 3. So, I will write here 145. We will done 145 by 5. Okay, so 5 to the 10, 5 9 45. Okay, 29. 29. 29 can be done by 29 cannot be divided by any number except 29 and 1. So we will write 29 here only. Okay, we will write divided by 29 only. So we get 0. So we will pair it. 2 into 2 comes in one pair. Then this 2 remains, and 3 into 3 comes into pair. But 5 and 29 do not make a pair. So 2, 5 and 29 do not make a pair. That's why it is not a perfect square. 17640 is not a perfect square. Okay. But we can make it a perfect square if we multiply it by 2 and 5 and 29 once again. But 17640 is not a perfect square. Now I will go ahead. Check whether this 36350. Okay, so this is the second example. We will do this also. 63504. Okay, so this is the number and we will divide it by prime factorization method. We will divide it by 2. 2 3 are 6, 2 1 are 2, 2 7 are 14, 2 5 are 10, 2 are 4. Okay, and now comes 31752. Okay, this is 1. Then 2 divided by 1 is equal to 11 5, and here comes okay. So well, once more divided by 2. Okay, so t is okay. So once more we will divide by 2. Okay. Okay, so 3 9. So our results come 3 9 6 9. So it can be divided by 3. So we will divide it by 3. Okay, so we will divide 1 2 3. Okay, so 1 2 3 1 3 2. Okay, we will divide by 3 once again, and so okay, so our comes 441. 441. So 441 can be divided by 3 again. So 3 1 are 3, 4 are 12, 3 21, 147. 147 can also be divided by 3, so we will divide it by 3. 3 12, 3 9 27. Okay, 49. That is 7 into 7 is 49. Okay, we will write 7 into 7. So 2 into 2 comes in a pair. Okay, then 2 into 2 also comes in a pair. Then 3 into 3 comes in a pair. And then again 3 into 3 comes into pair. Then 7 into 7 also comes in a pair. So this is in a pair. This makes a pair. This makes a pair. This makes a pair. This also makes a pair. So this is a perfect square. Means 63504 is a perfect square. Okay, this is a perfect square. And the number whose square is 6305 is we will take one number from every pair. So we will take 2 from here, also 2 from here, 3 from here, 3 and from here 7. Okay, so 2 into 2 4 4. Okay, 4 3 12 12 3. Okay, so we can find the square of this number by, we can check if it is perfect square by prime factorization method. Now we will go ahead. Okay, so imagine there are many numbers and we have to check if it is a perfect square or not. So we cannot do prime factorization method for every one of them. So we need to learn about the properties of square. By learning the properties of square, we can classify some of the square numbers that can be square numbers. Okay, some of the numbers that can be square numbers, then check it with the help of prime factorization method. So first property of any square is natural number having 2 3 7 or 8 at the unit place can never be a perfect square. In other words, we can say that a perfect square only contains 1 4 5 6 or 9 at the unit place. Note, you have to note that it is not compulsory that every natural number having 1 4 5 6 or 9 at their unit place would be a perfect square. Okay, so we have done an example previously. We will check if the see 63504. Okay, this was a perfect square and its last unit digit contains 4, which, and the property 1 also shows that any perfect square would have 1 4 5 6 or 9 at their unit place. Property 2. If the perfect square has a 0 at the unit place, then it will only have even numbers of zeros from the unit place to be a perfect square. Okay, 100 is a perfect square, 10,000 is a perfect square, but 1000 is not a perfect square. Why? Because 1000 if we count the number of zeros in it, then it will be an odd number. But 100 and 10,000 have even number of zeros. A natural number having odd numbers of 0 from the unit place can never be a perfect square. But it is not compulsory or mandatory that all the natural numbers having even number of zeros from the unit place would be a perfect square. They may or may not be a perfect square. So there are some exceptions in properties also, but we can check. That's why I'm saying we can classify some of the numbers using the properties and then check the classified numbers using prime factorization method. This process will give us more time. Okay, will take less time to solve it. Property 3. The square of even number will always be even and the odd number will always be odd. Okay, so let's so any number, even number, will always, its square will always be an even number. Suppose 2 square is 4. Let's suppose 6 is a 36, so 6 square is also 36. Okay, so even number square is also always even and odd number square is odd. 5 into 5 is 25. 5 square is 25. 25 is odd and 5 is also odd. Property 4. A perfect square when divided by 3 will have a remainder 0 or 1. Every natural number having 0 and 1 as remainder when divided by 3 may or may not be a perfect square. Note, 1 is the exception for this property. There are two notes here, two exceptions in this property, and this is about 4 also. 4, if you divide any number by 4, the remainder of 4 will be also 0 and 1. Suppose let's check 4. Suppose let's check if we take perfect square and divided by. Okay, let's check 5. 5 or 25. Okay, 25 is a perfect square. So just a minute. 25. Okay, so 25. 25 and divided by 4 will give a remainder of 1. Okay, so it is a perfect square. Okay, this property is sorry, this property is good for perfect squares. Natural. Okay, this table shows the for possible remainders when divided by sum of the divisors. Like you can see, if any number is divided by 3, it will give 0 and 1. If any number is divided by 4, it will also give 0 and 1. If any number is divided by 5, it will give 0, 1 and 4. If any number means a possible square only, a perfect square only. When a perfect square is divided by 3, it will give 0 and 1 also. A perfect square divided by 4 will also give 0 and 1. A perfect square divided by 5 will also will give 0, 1 and 4. Okay. When divided by 7, a perfect square, it will give 0, 1, 2 or 4. Okay, this goes on like 11 for 11 and 13 also. For when we divide by 11, the remainder could be 0, 1, 3, 4, 5 or 9. When divided by 13, it will give 0, 1, 3, 4, 5, 9, 10 or 12. So now we will go to property 6. The unit digit of a square of a natural number is the unit digit of the square of the digit at units place of a given natural number. You can see here, let's do an example. If suppose our number is 1 2 3 5. Okay, 1 2 3 5. So what would be the unit place, what would be the number at unit place of the square of this number? So if so to check what will be the unit place of the square of this number, so we have to just multiply the last number by itself. So 5 into 5 is 25. Okay, so the last number, the unit place would be 5 of the number. Okay, you can check with any number. Suppose I will just erase it. Suppose with 1 2 3 4 5 6 7. Okay, so what would be the in the unit place of this square of if we multiply if we take the square of this number, what would be in the unit place? So to check what will be in the unit place, you just need to multiply the last unit digit of this number, that is 7 into 7 is equal to 49. So the unit digit would be 9 here. Okay, so here is the table again. So in this property only 0, if you divide it by 0, it will give 0. If you divide by 1 or 9, it will give 1. If divided by 2 or 8, it will give 4. Divided by 3 and 7, it will give, multiplied by 3, or if it is 3 or 7, then it will give 9. If it is at 4 or 6 at the unit place, then it will give 6. If it is 5 at unit place, then it will give 5. Okay, why? Because 0 into 0 is 0, 1 into 1 is 1, and 9 into 9 is 81. So unit digit of 81 is 1. So the square would have 1 at the unit place. Okay, 2 into 2 is 4, 8 and 8 to 8 is 64, that is 4 also. 3 into 3 is 9, 7 into 7 is 49, 4 into 4 is 16, 16 into 6 is 36, and 5 into 5 is 25. Now we will go to property 7. If n is a perfect square, then 2n can never be a perfect square. Example, 4 is a perfect square, n is equal to 4. So 2n, that is 2 into 4 is equal to 8, which is not a perfect square. Let's check this with another example. So suppose n is equal to 16, then 2n, that is 16 into 2, that is 32, would never be a perfect square. 16 is a perfect square, 4 into 4 is 16, but 32 is not a perfect square. Property 8. For even natural number, every natural number n plus 1, whole square minus n square is equal to n plus 1 plus n. Okay. Okay, this is a formula. Okay, this is a formula. Any number n and a natural number n. Suppose 9 plus 1. Suppose let's check this with the help of sorry. Let's check with this with the help of 2. Uh, 2 2 plus 1 whole square minus 2 square. Okay, so 2 plus 1 is 3, 3 square is 9, minus 2 square is 4. Okay, 9 minus 4 is equal to 5. And if we check this with this is equal to n is equal to 2 plus 1 plus 2. Okay, 2 plus 1 plus 2, that is 2 plus 1 is 3 plus 2 is equal to 5. Okay, both results with 5. Okay, this also result is 5 and this result is also 5. So this is equal. Okay, so this is equal. So this property is true. Property 9. The square of a natural number n is equal to the sum of the first n odd natural number. Suppose n square is 1, so 2 square would be 1 plus 3. 3 square would be 1 plus 3 plus 5. 4 square would be 1 plus 3 plus 5 plus 7. Okay, so 5 square would be 1. 5 square would be 1 plus 3 plus 5 plus 7 plus 9. Okay, 5 square would be 1 plus 3 plus 5 plus 7 plus 9. If we take 6 square, then it should be 1 plus 3 plus 5 plus 7 plus 9 plus 11. Okay, this will go on like this only. Okay, so this is the property 9. Now we will go ahead to the patterns of the natural number. Now we had learned about the properties of natural number. Now we will learn about the patterns of any square number or perfect square. Okay. There are many patterns which are very interesting, and we will learn about this here. Okay, so first we will learn about pattern 1. Okay, in this pattern, the sum of two consecutive triangular numbers is a square number. Sum of two consecutive triangular numbers. So what are triangular numbers? Triangular numbers are the numbers whose dot patterns can be arranged as triangles, are called triangular numbers. Example 1, 3, 6, 10, etc. Okay, we'll check this. So we can, one dot is 1. Okay, this is a triangle. We can check this. 3 dots here, 1, 2, 3. Okay, this is a triangle. Then 6, 1, 2, 3, 4, 5, 6. This is also a triangle. And you can check this with the 10 also. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is also a triangle. Okay, so it's a saying that two consecutive, this is 3, this is 6, and this is 10. Two consecutive triangular number, sum of two consecutive triangular number will always be a square number. So 1 plus 0 is 1. 1 plus 3 is 4. 4 is also a square number. 3 plus 6 is 9, which is a square number of 3 into 3 is 9. Okay, 2 into 2 is 4. 6 plus 10 is equal to 16. 4 into 4 is 16. Okay, so this goes on like this. You can see here also, these are the triangular numbers. These are the triangular numbers, and these are the square numbers. Okay, you can see here, triangular numbers 1, 3, 6, and 10 are the triangular numbers, and the 1, 4, 9, 16 are perfect squares, are the square numbers. You can see here that 1 plus 3 is equal to 4, 3 plus 6 is equal to 9, 6 plus 10 is equal to 16. Okay, this shows a diagram. Dot patterns. Okay, dot patterns. Diagram of dot patterns. So pattern 2. All the numbers between n square and n plus 1 square would be equal to 2n. Example, n is equal to 1, 1 square is equal to 1, 2 square is equal to 4. Number between 1 and 4 are 2 and 3, which is 2 into n, that is 1 into 2 is equal to 2 and 3. Two numbers are there, 2 and 3. So the natural numbers 1 and 4 are 2, which is also equal to 2n. Okay, we will check this with 3 also. Let's check this with 2 square and 3 square. 2 square is 4 and 3 square is 9. Okay, so between is 5, 6, 7, 8. Okay, okay. So 4. Okay, so here is 2n. It is saying 2n. Okay, so 2n is equal to 2 into 2 is equal to 4. So here are 4 digits, 1, 2, 3 and 4. Okay, so this property is, this pattern of the square number is 2, and this was very interesting actually. Now we will learn about consecutive square numbers. Okay, these are the numbers, non-perfect square numbers between two consecutive numbers. Okay, so this is the table for this pattern. Okay, so 1 square and 2 square between is 2 and 3. 2 is equal to 2 into 2 1. Okay, 2 square is equal to 3 square. 5 there are 4 numbers. Here are 6 numbers. Here 8 numbers. Okay, so this is how this was. Okay. Pattern 3. The sum of first n odd numbers is n square. We have checked this in the property also. If n is 1, then 1 square would be 1. 1. 2 square is 4, and 1 plus 3 is equal to 4. 1 plus 3 plus 5 is equal to 9, which is 3 square. 1 plus 3 plus 5 plus 7 is equal to 16, which is 4 square. This was a property of square numbers also. This is a pattern also. Pattern 4. If 1 is added to the product of two consecutive or even number, then the result will be equal to the square of the number between them. 1 into 3 is equal, plus 1 is equal to 4 is equal to 2 square. 2 into 4 plus 1 is equal to 9 is equal to 3 square. Pattern, now we will go to pattern 5. The square of any odd natural number will be expressed as the sum of two consecutive natural number. 3 square is equal to 9, which is 3 square is 9, which is equal to 4 plus 5. 5 square is 25, which is equal to 12 and 13. 7 square is 49, that is equal to 12 and 24 plus 25. Now we will go to pattern 6. Square of natural numbers having all digit 1 as a pattern will have a pattern, that is 11 square is equal to 121. 111 square is 12321. 1111 square is 123431. 11,000 111 square is also is 123454321. Okay, so this pattern goes on like this. You can see here, if there are 2 digits, then it will go till 2. If it has 3 digits, then it will go to 3 and will return. Okay, it will go and then return. If it has 4 numbers, then it will go till 4 and then return. If it has 5 digits, then it will go till 5 and then return. This pattern goes on like this. Natural number having all digit as 1 square into the sum of the all digit of the square of all natural numbers equal to result that is equal to the number into the number digits. We will do this with an example. That is 11 square is equal to 121. So 121 into 1 plus 2 plus 1 is equal to 484 is equal to 11 square is equal into 2 is equal to 484, that is 22 square. Okay, you can check with 1 square also. 1 2 3 2 1 into 1 plus 2 plus 3 plus 2 plus 1 is equal to 1 1 1 square into 4, that is 1 1 0 8 8 9 is equal to 3 3 square 3 3 3 square. So you can see this pattern. This is very interesting pattern. This is a very good pattern also. You can learn this. Now we'll go to shortcuts of to find squares. We had learned till now how to classify if a square is a perfect square or not. But now we will learn about the shortcuts to find any square number. So first we will learn about column methods. Okay, this method is convenient for finding square of two-digit numbers only. In this method, we can take two variables a and b. Here a represents the number at the tens place and b represents the number at unit place. Step 1. Make three columns. Write a square in first column, 2ab in the second column. In the third column, write b square. Okay. A square, then 2ab, then b square. Underline the unit digit of b square. Add the unit digit of b square in column 2. Underline the unit digit of second column and add it to the first column. Write the number obtained in column 1 and write the underlined number next to the number obtained in column 1. The number that you get in step 4 is the square of the initial two-digit number. Okay, we will do step by step with an example. First, we'll learn about 89 via column method. Okay, to find 81, first we will check here. Step 1 is make three columns. Write a square in first column, 2ab in second column and b square in third column. We will make three columns. Okay, 1, 2. Here we will write a square, 2ab, then b square. So here a is equal, here I will write here a is equal to 8 and b is equal to 9. So a square, that is 8, 8 square is 64, 9, that is b here, 9 square is 81, 2 into 8 into 9, 64, 2 into 8 is equal to 16 into 9, 144 and 81. Okay, so 144 we will get. Now we will add the unit digit of this number 1, that is 1 here. So it will come, we will write 81 here and 144 plus 1 is 145. This will underline this and we will add here 64 plus 5. 64 plus 5 is equal to 69. Here we will take 5 and here we will take 1. So the square of 89 is 6951. Okay, the square of 89 is 6951. This is with the help, I had calculated this with the help of column method. This is the column method. Okay, now we will learn about diagonal method. This method is applicable to find square of any number. We will do this with the example. Find the square of 349 via diagonal method. Okay, so first we will make a square. First we will make three columns, 1, 2 and 3, because it has 3 digits. Any number of digits, suppose it has 4 digits, then we will make 4 columns, both horizontally and both diagonally, both vertically, and we will make a square around it. Then we will write the number above every box. We had made this is a box, this is a box, this is a box. Okay, all this, and here also 349. Then we will make diagonals in every boxes like this. Then we will multiply 3, that is 0, 9. 3 4 are 12. Here 27. 4 3 are 12. 16. 6. Okay, and 9 9 is 81. So this is the number. Now we will make diagonals here like this and write. Now we will add the numbers. Here it is 1. Sorry, here it is 1 and in this diagonal, that is 6 plus 8 plus 6. That is 24. We will write 4 here and we will carry a 2 here. Okay, so 2 plus 7 is 9 plus 3, 9 plus 3 plus 6 plus 3 plus 7. Sorry, but I will do this again. So here comes 1, then 6 plus 8 plus 6, 0, and we will carry over 2 plus 7 is 9, 8 will carry over 2, 2 plus 2 is 4 plus 2 plus 1 plus 2 plus 2, 11. We will carry 1, 1 plus 1 is 2 plus 9, 11 plus 1 is 12. So 2, we will carry 1, 1 plus 0 is 1. So the number would be, 1, 1 2 1 8 0 1. So 349 square would be 121,801. Okay, so 121,801 is a perfect square. Now I will go ahead. Methods to find square. So first method is, this is only for digits having 5. Okay, we will take a5 here. A is the digit at the tens place and 5 is at the unit place. The square would end with 25 as 5 square is 25, and we will add a into a plus 1 before 25. That is, let's check this with example 85. A is equal to 5 and 85. Okay, so we will add 25 here, and before it will add 8, that is 8 into 9, 7225. The square of 85 would be 7225. Now we will go to the second method. The method 2 is 56. We will take 5a here also, and 5 is a digit at 10 place and a will remain at unit place. It will be as 25 plus a into 100 plus a square. Okay, so we will check 25 plus a, that is equal to 25 plus 6 is equal to 31 into 100 plus 6 square, 3100 plus 36. So the answer would be 3136. The square of 56 would be 3136. Now I'll go ahead to the method 3. Here we will check this with the 527. We will take 5ab here, and a is the digit at tens place and b will remain at unit place. 5ab square is equal to 250 plus ab into 1000 plus ab square. We will check 250 plus ab, that is 27, and the result is 277 into 1000 plus AB, that is 27 square. So 277 is 277 into 1, 2, 3 plus, and 27 square is 279. Okay, so 277,000 plus 279 is 277,279. So the result will be 277,279. Sorry, I have taken wrong example here. I will take another example here. but first we will take n5. N is a digit from tens place, and 5 will remain at unit place. The square tens will contain 5, and unit digit 5 as a square of 5 is 25. Then we will find the result of n plus 1 and write it before 25. Okay, so we will take n5. Suppose we will take 75 here as an example. So we will write 25 here, and n plus 1, that is 7 into 8, 56. That is, so the square of 75 would be 5625. Uh, Thank you. I hope you have enjoyed. Now we will learn about the method that I have I have done it in the previous of this chapter. Okay, in the beginning of the chapter. So we will take here 83 as an example. 83 square. So the first is to find is we will first take this is a trick of Vedic math. Okay, so we will take 3 here, and 3 into 3 is 9. We will make 3 columns, 1, 2 and 3. Okay, in the first column we will write 3 square. In the second column, in the first column we will write 8 square, and here 8 into 3 into 2. Okay, it goes on like every every square number. We will also do this with the help of second example. So 3 square is 9, 8 4 and 8 into 48. Okay, so we will do this like this: 64, 48 and 09, because it will write 09 because it is a 0. So we will add 9, 0 plus 8, 8, 4 plus 4 is 8, and here comes 6. So 83 square is equal to 6889. Now we will do this with another example also. And this time we will take, suppose this time I will take, this is only for 2-digit number. Now I will take 20. Suppose 28. Okay, 28. I will do this for 28. Okay, we will take 3 columns here also. 8 square is 64, and 2 square is 4. Okay, so 2 into 8 is 16 into 2 is equal to 32. So we will do this again: 0, 4, 3, 2, 6, 4. Okay, we will add 4 here. 6 plus 2 is 8, and 4 plus 3 is 784. So 28 square is 784. So this is the first method. Now I will show you the second method that I have shown you in previously of this chapter. For as an example, this method is also an Vedic math method. So this is for the number that is near to 100, 1000, 10,000. Okay, and above also 10,000, 100,000. Okay, it is near these numbers. So for first we will take 103 as an example. Here I will take base as 100. Base is equal to 100. Okay, and I will minus this number with the help with this number. So 103 minus 100 is equal to 3. Okay, now I will make 2 columns here and here. Here I will write 103 plus the difference. This is the difference plus 3, and here the square of the difference. Okay, so 103 is 106, and here 9. Okay, we will check. Here is 2 digit of 0 here. Okay, in the base there are 2 digit of 0. Okay, 2 digit of 0. So after 106, I have to put 2 digit two-digit number. Okay, this is a one-digit number 9, so I will write a 0 and then 9. So the square of 103 is equal to 10609. I will do this with another example. Now with the base of 10. Now I will take the base as 10 for a number that has a base of 10. Now suppose the number is 13. So the base is 10. Base is equal to 10. So I will check 13 minus 10 is equal to 3. And 13 plus 3, and here 3 square. 13 plus 3 is 16 and 3 square is 9. So one digit, so the square of 13 is 169. Okay, this can be done with any number near to 1000. Okay, now check. Now let's check with the now check with 98. 98 is near to 100, so the base would be 100. Okay, 98's base would be 100. So 98 minus 100 is equal to minus 2. Okay, is equal to minus 2. So how would we do this with this? So 98 plus minus 2, and here I will write minus 2 square. So 98 plus minus 2 is equal to 96, and here is minus 2 square is 4. So two digit here, there are two numbers of zeros, so I will take two digits, 9604, two digit at the last, but this is one digit, so I will put 0 here. So then so the number is, so the square of 98 is 9604. Hope you learned something new in this chapter. Thanks to watch. Hope you enjoyed.